going to be doing Pytorch today. We're going to be predicting where the user is going to click on the screen. Thank you to Quantified Quantum for setting this up for us. We had the base game. As you see here, we got the base code already. None of the AI is there, and we're going to add in the AI part, and we're going to see if we can make something work. I don't know. It's not a lot of data, and so we'll try to do reinforcement learning. Very small amounts of data. So where are we going to get it to work? I don't know. We'll find out. We'll see if we can build the model, and we'll see how far we get. We might not finish it today. Actually, let's do this. Let's open this first. So let's run this game. PyGame, Python, main. That should work. Okay, great. Okay. So we've got our main canvas here. Some circle in the middle for some reason. And then we can see where we're clicking. This is kind of neat. I like that. Good start. So what we need to do is capture these inputs, which are being captured into a list right now. I do believe it's a list somewhere. There's a list in here somewhere. And it's storing all of these click positions. So this should be the maximum, near the maximum corner here. Set us up with this Python class, the base class. A really simple application. And it lets you click on the screen. And what we need to do is have an AI predict where you're going to click next. So we need to think this through. We got to think this through the right way, because if we click and then we immediately show where we think the user's going to click next, then you've essentially predicted the future and you've changed the course of things, because you showed the user where the AI thinks you're going to click, and they're just going to go somewhere else. So like if you click here, but the AI thinks you're going to click there next, and you show both of the dots, it's a problem, right? Because you're changing the future at that point. So we need to hide it until the user clicks. So we need to click, and then the AI also needs to simultaneously click with where it thought that it was going to be clicking next. Let's get our Pytorch going here. So import Pytorch, and we're probably going to do a simple, there's nothing advanced or complex here because this is simple vector in, vector out. I would like to transform it so that we normalize it. I would like to have a normalization step. Okay. Pytorch, and then import, let's see here. Or it's not Pytorch, it's called Torch. And then, let's see. From Torch, import neural network. So we want neural network, and then we're gonna want to set up our module. So let's see, we'll try to copy this format here. All right, here we go. We'll call this the predictor, and then we'll have the model. We also need the optimizer, and we go back to my reference file. So let's go project/projects, AI game. I think, let's see here. It would be game.py. Perfect. Okay. So we got Pytorch. We need to grab this. Where's my AI at? So we already have some stuff that we could just copy and paste from a previous project. Here we go. This is what I'm looking for. There we go. Optimizer, loss. These are good. Those are good. Features, labels, outputs. I don't think we need this information. We do need learning, though. We want the learning rate. I want the learning rate here. And the model, where's the model at? Will be just none for now. Okay, perfect. Graciously gave us this base file, and we're starting to mess with it right now. We already started to open it up. So we added a predictor class, and the idea is it's going to predict where the user clicks next. We're gonna have to do some. So I want optim. There we go. Okay. Losses gonna be that. What else? We need more. The learning rate. We'll just leave it there for now. We don't need this. And the model needs to be set as well. Or is it? No. I think we can do this. I think we can figure this out. All right. So losses list less model. Okay, perfect. And it is going to be something like this. I think we could probably do something like this. Let's see here. Model. Sequential 10H. Yes, because we're going to do, it's basically exactly the same thing that we did in our previous game where the AI was tracking user coordinates. So with the user coordinates, we want to use a similar model here. But the input is just going to be 2. Wait, no. No. We could do a lot more than 2. So we could do multiple things. We can track the before they click if we wanted to. We could also track every click in a sequence, which I think might be better, although we'd need more data because it's a larger input. So maybe what we could do is do 6. So we track last 3 click positions, right? So I think that's what we do. That's why it is. So it's XY, XY, XY. Multiple XYs. So we've got our model. Torch looks good. Multiple inputs. And then we've got our loss. We've got our optimizer. Okay, with the models, parameters, good. MSE loss, when you calculate loss. Okay, perfect. Okay. So now what we need to do is we should run the data through our model once. I think we could do that. I think we can do that. Okay. Let me close that. Let's bring it up over here so it's a little bit easier to deal with. We want the last 3, I believe, is what we're looking for. So this will be the features. So if we do -3, it's just going to be the last. Oh, it's just going to be, okay, so we need to call in this. There we go. So that's the first 3. What if we did it like this? Okay, that's so what if we, what would that look like? 1, -1. Okay, so -4, -1, which gives us the 3 last clicks. And then, so that's what we need. That's what we need. So this will give us the features. Paste. And then the label will be the last position, -1. So we need to, we can't start training the AI until it's got enough clicks. So you need to click a bunch first. We've got all of our clicks here. Okay, bring it back over. Okay, so we need to, I want to make this into a function. Let's do predictions. We'll make this a function and we'll send in the marker. So that's what we'll do. Predictions and markers. So we need to def predictions and we need a marker. There we go. We transform. Okay. So I want a transformer here. I want to be able to define a transformer that normalizes the coordinate inputs because they're going to be very big numbers, right? So they need to be a number between like +1 and -1, around that range. Currently, the numbers are large. They're very large. Look here. So you can see here on the screen. So let's take a look here. Control V. There you go. So you can see here on the screen, right here, these numbers are very large. Too big to go into the AI. So we need to normalize them. We need to essentially divide by the width of the window and the height of the window. Base code encoded equals something, and then decoded equals something on the output. Here we go. Output something. Okay, so we need to do these steps here. We need to do our encoding. We have to do it using Pytorch. We've got our distribution. I think that's what it looks like. I think, although we're going to test it out. We're going to test it out. I'm not sure if this is what I really want. We'll try it. Okay. So let's see if it'll run train pass. Let's see if we have anything broken here. All right. 125, 125. Okay. So predictor. That's right. There we go. So we got our predictor here. We got our gain, frames per second. Might as well bring this up here at the top. Marker. All right. Got our marker. Wait, point marker. This could go up here. Keep things going. All right. Okay. All right. Making it good. Now we've got our predictions, which is going to have the AI predict where the player's movements or the next click is going to be. Okay. predictor, and that it gets passed in there. So that way we can do the analysis on the data with reinforcement learning and then do the predictions for every click. Well, actually, let's see here. I need to think about that for one moment. I need to think about that because we might overfit if we can. We want only when there's new data. Okay, so that's something else that we have to do. Only train and predict when there's new data. When there's essentially a click occurs. When a click occurs. Okay. Which we could run in here. So to do only run when a click occurs. And we can do that pretty easily by detecting and storing state in our object to see if the length of the pointers are, or if there just was a number of clicks. We can just track the number of clicks and see if we are on track with the number of clicks, something like that. I think we could do that. We could do something simple like that. Track the number of clicks. Okay, so self dot click 0. Okay. So we need to increment this every time there's more clicks. We go back over here to the code. Points equals, where do we want to do this? Let's do this over here. Let's see here. Clicks. Self.clicks. Yes. So we got to do this one first. This one's going to be first. Okay. Points. It's going to be exactly the same as if return. Because we only want to do this on a. We want to only run AI when user clicks. Okay. And then only allow AI to run if we have enough data samples. That's what that is. That's what this is about. Okay. All right. We did the to-do. We need the clicks to be, we need to increment the clicks. Okay. Also, it's going to not be self. It's going to be predictor here. We also probably need the game object for later use to draw on the screen. That's what we need there. Let's see. Stephen, what's tour fixation? I don't know. What do you mean by that? Did that, bro? Okay, I would definitely reach out to you for any help in case I switch to AI. Nice. Yeah, that's the way to go. Merry Christmas, Justin. Merry Christmas. How building a point predictor. The user clicks on the screen, and the AI is going to predict where the user clicks next, which we're probably going to have to continue on Monday because we're basically out of time right now. We're out of time. We're like over time right now. Let's see if we can keep going though for a little bit. I would really like to be able to get the clicks to run through the model and encode and get an output. We need, before that'll work, the clicking, the point list here is not permanent. It is temporary. It gets removed. So what we could do, we don't want to render all the circles. So I need a separate point list. I need a separate, where we do the pushing, I need to push as well. So right here, okay. So we need a separate list. Point list, self.ai point list. Append. We just do the same thing here. There we go. Yes, it's stricter JavaScript. Yep, you got it. It's stricter JavaScript. It certainly is. Because there's a transpiler that lives on top of it that needs a specific structure mandated in order for it to actually transpile the JavaScript. Aiden Harris, hey, how's it good to see you. Welcome on in. We're almost about ready to run our AI model for its first forward pass. There's no training yet. It doesn't train yet, but we are going to run through the forward pass here. I do believe that is the incorrect way to do that. We have to do it like that. There we go. Forward. Forward. Good, 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 good. Okay, excellent. Predictor output. And then it will run the forward, encodes it, throws it to the model, and returns the output. We need to decode it, though. This is a to-do item here. Okay, model. Perfect. Wait. Yes, this should do it. And the forward function will get executed by the call, the double underscore call method, which looks like this. It's the call, underscore, which is built in to the in-end module. So all we have to do in order to run this forward is to run the predictor. We're going to find out, is it going to work or are we going to crash? All right, got our crash here. All right, so right. Number of clicks. Okay, let's see here. Number click. Never click. Why is that a problem? I think that's exactly where it is. Let's see here. Run it again. All right, click. All right, okay, cool. That was where the error was. All right, so we got a lot of clickety clicks. All right, now let's hide the click print because we don't need that anymore. We will print number of clicks here. Let's try that again to make sure that works. Click. Yep. Okay, yeah, that looks good. Clicks 9, 10, 11, 12. Perfect. Excellent. We need to do something different here. On the append, this we need to capture differently. X, point dot y, make X and Y. So these are our clicks. And we need to do is we need to flatten it. I think there is a nice happy flattener. V2 dot flatten. Can we do that? Is that possible? Is that something that'll work? Also, this won't do what I want it to do, I'm pretty sure. So we need to fix that as well. Where is this at? Features. Looks good. So these will be the X and Y coordinates of each of the events, and then we'll flatten it. Encoder, print before and after. Perfect. So we've got all of our coordinates, and I need to normalize it as input. I need to encode it. So that's what we're doing right now. We're just working on encoding. Obviously, I can pre-encode it manually myself. I am doing something that I want to try to learn, is creating a fully unbroken graph. So it's raw input data, unchanged input data, just XY coordinates of the mouse where it was clicked. The XY coordinates of the click. And we're storing that into a list of clicks. And that will be the input data or the features for the model. We need to convert that list into a tensor, and we need to convert the raw coordinates into a number between -1 and +1, or like just maybe, a small number that the AI can understand when it's doing its feed forward. Otherwise, the numbers are too big and it can't learn, and it will cause, the inability to activate properly all of the parameters or the neurons, right? It won't activate properly. So we need to normalize the data or encode it. We need to encode the data. And I need to find a way to do that. That's what we're currently doing. Forgot the batch. I basically forgot the batch is what I forgot. I have to try this out on incurses and library in C because I don't know Python really well. That sounds like a good project. Good idea. Code lengthens. Give it a try. Would give it a try. Okay, so I think the jam. I'm pretty sure all I needed. I didn't do batching. So I'm doing the forward on a non-batch, and it's giving me every integer rather than the series. And I needed to give me the series. So I'm pretty sure this is what was the problem right here. So let me save that and run, and that should give us what I'm looking for. Yeah. It still didn't work. Why not? Int object not subscriptable. Is it not? Did I predictor? So that would be a forward on the features. Which perfectly fine. It's perfectly fine. La la la. What is it then? Try something really simple. This before and after should never occur. Like these guys here. So it's getting to a wrong spot for one. So that's part of the problem. Okay, so part of the problem is it's running the encoder before we have enough data. So it should have never gotten there. 2 clicks, 4 clicks. Well, 4 clicks is still not enough. Okay. I got it. Okay. Why is it? It's double counting it. So that's a problem. Oh, right. So that'll fix that part. And it needs to be 6. Or, well, 3, right? It needs to be 3. Okay. Building an AI that's going to track the clicks and predict the clicks of a user. So you could do things like seeing if it's really human or if it's an AI, right? So you can see if like there's organic clicks, and you can see if an AI agent that's driving a browser is clicking or if a human is clicking. You could do things like that. For now, though, we're just going to try to do predicting the next click. Something simple like that. All right, let's see if this works. I don't know if that'll work. Okay. So it doesn't like that because... So if it doesn't like that, how do we transform it properly? And then we have to do a reshape. All right, so I'm not familiar with this code. This is just what the docs are saying. Okay, so that's readable. We can read that pretty easily. Let's double check this. Lambda x chords view -1 2 game width height, right? Because the x, y, and then reshape. Will that work the way I want it to? I think it will, although I think we have to adjust some numbers here. Do you have any recommendations for learning Torch transformers? Basically doing what we're doing right now. We've got a project and we've got a goal and we're trying to get it to work, basically. And that's the best way to learn, getting your hands on the keyboard. That's the best way. Otherwise, it's just asking the AI to do everything for you, and you don't really have to learn anything at that point. Though, if you are in the learning, I don't even know if what I'm doing right now, I don't even know if we have to keep doing this anymore. Like, seriously, like, do I have to keep learning these kinds of things, or does the AI just take care of everything for us going forward? Right? It seems like the latter, doesn't it? Doesn't it seem like the AI is going to take care of everything for us? But I do have to get going. I'm like way over time. So this will be, if we get this working right here, it's just the encoding. We're wrapping up. We're wrapping up. I have to change some stuff to get that to work right. AI underscore point list append. We have to redo this like this. Like this. Y. That. AI point list. Now it's going to be bigger. So we need to do 6 and 2. Like that. Number of clicks. It's like not. It's no longer number of clicks. It's number of points.